This lesson will be on polynomial long division, so our objective is to divide two polynomials using polynomial long division. We're going to start by talking about using it with numbers. So if we're taking 737 divided by 4, long division is set up by putting the 4 in this spot, the 737 here. The 4 is called the divisor. The 737 is called the dividend. And how you do division is you first of all start by saying 4 goes into 7 how many times? Well, it goes in once with a 4, and then we subtract and get a 3. Bring the next 3 down. 4 goes into 33 how many times? Well, it goes in 8 times. 8 times 4 is 32. Subtract and you get 1. Bring down the 7. 4 goes into 17 another 4 times. And then 4 times 4 is 16. Subtract and you get 1. So what we get is 184 with the remainder. We call that number down at the bottom the remainder. And we call the 184, that's called the quotient. Okay, so on this, when we want to then format our answer, how we write it is we take the quotient and we add to it the remainder over the divisor. So that's going to be how we format each of our answers in these long division problems. So this problem we have here, how it will be written is, for an answer would be 184, which is the quotient, plus the remainder, which is 1, over the divisor, which is 4. So 184 plus 1/4. Now let's do it with polynomials. So the setup will look very similar, x plus 4 divided into x squared plus 11x plus 30. You ask the same sort of question. You say x times what gives you x squared? Well, that's another x. X times x is x squared. X times 4 is 4x. Now, we're going to use the same operation going down. We're going to subtract. I put parentheses around that because it helps to be able to remember to subtract the second one so we don't forget. X squared over x minus x squared is 0. 11x minus 4x is going to be 7x. Bring down the next term, plus 30. X times what gives you 7x, so that's a plus 7. 7 times x is 7x. 7 times 4 is 28. We're going to subtract those. 7x minus 7x is gone. 30 minus 28 is a 2. So we get a remainder of 2. So our final answer, when we write this out, will be the quotient, x plus 7, plus the remainder, 2, over the divisor, x plus 4. That's how we write the answer to that polynomial long division problem. Let's try the next one. We're going to do 2x plus 3, that's our divisor, divided into 6x squared plus 11x plus 8. So 2x times what gives me the 6x squared? So 2x multiplied by 3x will give me that 6x squared. So 3x times 2x is 6x squared. 3x times 3 is a 9x. And we're going to subtract straight down. 6x squared minus 6x squared is 0. 11x minus 9x is 2x. Bring down the 8. Yes, the question, 2x times what gives you 2x? Well, that's just a 1. So 1 times 2x is 2x. 1 times the 3 is just a 3. We're going to subtract. 2x minus 2x is 0. 8 minus 3 is equal to 5. So we have our quotient is 3x plus 1. And our remainder is 5 over the divisor, 2x plus 3. Now the next one we'll set up in just like we were doing the other ones. This one we're going to have a little bit more of a challenge with subtraction. So I want you to pay close attention as we do this one when we subtract to make sure you don't make a mistake, especially when subtracting a negative. So x times what gives me the x squared? That's just an x. X times x is x squared. X times negative 3 is negative 3x. We're going to subtract, and I put the parentheses around it. Now remember, x squared minus x squared, that's 0, that's gone. But the next one, negative 6x minus a negative 3x, minus a negative is a plus, so you're going to get negative 6x plus 3x is going to give me a negative 3x. So bring down the plus 8. X times what gives me negative 3x? That's a negative 3. So negative 3x, and negative 3 times negative 3 is a plus 9. We're going to subtract that. Negative 3x plus 3x, because minus a negative will be no x's, 0x. And then 8 minus 9 is equal to negative 1. So our final answer will be the quotient, x minus 3, plus the remainder, negative 1, over the divisor, x minus 3. Okay, as we keep moving on, we're going to do one that has a missing term, because the ones we've been doing, if you notice, they were in standard form, they were in descending powers order, and no terms were missing. If you look at this, this one where we have the dividend, that dividend is missing an x squared term. So if we were to think of this as an x squared missing, what you want to do is you want to fill in 0 as a placeholder. When you're missing a term. So on this one, I'm going to think of it as 5x cubed plus 0x squared. So it's holding that place for the x squareds. That's to make sure everything lines up properly. Minus 50x minus 3 all over x minus 4. So let's set this one up. X minus 4 divided into, we're going to have 5x cubed plus 0x squared minus 50x minus 3. So x times what gives me 5x cubed? Well, that's a 5x squared. Notice that 5x squared is going to be lining up with the 0x squared. You need that placeholder. So 5x squared times x is 5x cubed. 5x squared times negative 4 is negative 20x squared. So the x squareds now line up since we put that 0x squared in that place. Subtract straight down, so 5x cubed minus 5x cubed is 0. 0x squared minus a negative is a plus 20x squared, so we get positive 20x squared. Bring down the negative 50x. X times what gives you 20x squared? Well, that's going to be a 20x. So 20x times x is going to be 20x squared. 20x times negative 4 is going to be a negative 80x. We're going to subtract straight down. Again, subtracting a lot of negatives on this problem. So there's no more x squareds when we subtract. Negative 50x minus a negative is going to be a positive. So negative 50x plus 80x will be 30x. Bring it down to negative 3. X times 30 gives me the 30x. So 30 times x is 30x. 30 times negative 4 is negative 120. I'm going to subtract straight down. No more x's. Negative 3 minus the negative is negative 3 plus 120, which gives me 117 as my remainder. So my final answer will be the the quotient, 5x squared plus 20x plus 30 plus the remainder, which is 117 over x minus 4. So our objective was to be able to divide polynomials using polynomial long division. Follow this process to set it up, to work through the problem until you get your quotient and your remainder, and then set up the final answer as your quotient plus the remainder over the divisor.